Okay, welcome. In this tutorial, we're going to have a look at functions, function notation. This first one will deal with simply the notation that we commonly meet and the idea of domain and range. There are a couple of following function tutorials that will deal with composition and creating inverse. The link should be popping up on the screen at some point for you to skip forward if you have either seen the first ones or you're confident with the notation and the idea of domain and range. Let's get straight into this with notation first. Function notation, one of those things that simply gives us instructions, tells us to do something. And so, for example, there's my instruction. I want you to square numbers. If I want you to square numbers, I could give you the notation like this. F of x equals x squared. You might see it similarly written, means the same thing. X maps to x squared. And of course we can change the letters. We could H, Y maps to y squared. In the end, what we've got here and what we've got to keep our eyes on is what we're being asked to do. And in this case, we're being asked to, there we go, looking slightly worried, but no need to. Keep our eyes on what the function is asking us to do, and we can be fine. Commonly seen notations. Consider this function. Slight change of heart there. I'm just going to change that function. Consider this function. And what I would like you to think about is the difference between these two. These two instructions or questions. Hopefully, you are confident to see this one as simply asking you to do something. Times by 3 and add 5. So this one is simply asking you that. This one, slightly different, is asking you that. So two slightly different questions to make sure that you are clear about. If we are asked f of 2 or f of 3 of f of 4, that's very much put a number in, and this notation f of x equals 2 is suggesting that we have got the answer 2 out and asks us what number we've got and will give us an equation to solve. So two slightly different expressions that sometimes get confused. Finally, domain and range. Let me set up a function. And let me consider these two things. Typically, what we are being asked here is we're being asked quite simply what numbers are going in and what numbers are coming out of the function. So domain, numbers in, range, numbers out, and we can pick and choose. For example, if I say to you, let me use some set notation, the numbers 0, 1 and 2 are the only things that I want you to put in. What are the three answers that will come out? Well, 2, 3 and 6 are the answers come out. So if 0, 1 and 2 go in, 2, 3 and 6 come out, and we say this maps to this. So domain in, range out, we can choose if we wish. What about thinking about putting all numbers in? Now, can we do this? X, element of all real numbers, any number on the number line. If we put all real numbers in, what comes out? One of the nicest ways that you're going to be able to tackle these questions is to quite simply look at a graph. If you look at a graph of a function, and if we put 0 in, we get 2 out, and that is that lowest point on the graph. If we look at the graph of a function, then typically what we see is we see all the numbers that are going in, real numbers, all the numbers on the number line there, and we will see numbers coming out, and typically you see all the answers to this function coming out, and those will be the y values. And very quickly a graph will show us numbers in, numbers out, and what we can see is that the green line, real numbers in, gives us numbers greater than or equal to 2 coming out. So we've got our range and our domain. Numbers in, numbers out. We can either pick and choose, or we are asking ourselves, okay, what about this function? F of x equals 1 over x minus 2. I'm going to just give you a quick sketch of this function to start with, x and y axes, and what we will see here is we will see this sort of shape, and then it goes to the x-axis but never quite gets there, and then what we will see is we will see this sort of shape coming back, and then it goes to the x-axis and never quite gets there. And what we see on this particular graph is we see that it never crosses or touches this line here, and this line here sits at x equals 2. So we see a graph here where we've got values going in, values coming out, but what we don't quite see is we don't quite see all numbers going in, all numbers coming out. So we have a question of domain and range here. Let's think about the biggest possible domain. Now, if we look at the x-axis, we should see many x values going in, but we are lacking one important x value there that we can't put in. We're not getting an answer out at 2. So x equals 2 is a problem, so x cannot be 2 in this function. And if you look and try and work that out, you'll see exactly why. 2 minus 2 is 0. 1 divided by 0 we say is undefined. There's no value. So the domain we cannot put 2 in, everything else is fine. And the range, what is the one answer that does not come out of this function? What one y value does not come out? Well, if you look at many y values, you will see, go along to the line, you'll see numbers coming out, but the one that you won't see coming out is 0. So all y values but not 0, all x values but not 2 gives us our biggest possible range and domain. And one last one. What about the idea h of x equals the square root of x plus 4? Domain and range. Now, I'm hoping you're thinking here, what numbers can I not put into this function? And if you've ever tried square rooting negative numbers, then you will appreciate that we can't deal with this function for negative numbers. If we choose a value of x, add 4, we ask ourselves which numbers can we not put in. So we are not allowed to have negative numbers. So x add 4 cannot be negative. We don't want numbers less than negative 4. So the numbers we do want here, we're going to be happy if we've got numbers greater than or equal to negative 4. Those are the numbers that we absolutely can use, and numbers less than -4 we can't, and we ask ourselves what numbers come out. You may be thinking about a graph of this. Let me show you a graph of this to help. And if you try and plot a graph of this, what you will see is you will see this sort of a graph. And there you go, you will see the numbers along the x-axis that you can put in, and you will quickly see the numbers that come out. There we go. So range and domain. Domain, numbers in, and range, numbers out. Choose them yourself, or have a look at a graph and see if there's any problems with any numbers, and consider the biggest domain and the biggest range. And there we go. Following tutorials will deal with the idea of composition of functions, combining different functions, and the idea of an inverse function, where we'll meet the idea of range and domain once again.